Hey, all you cool cats and kittens. It's Miss Willis here, ready to continue our notes on the lymphatic system, and we'll finish this up with body defenses and allergies. So, here we go. So, types of defenses we have innate and adaptive. Innate are ones that are non-specific, you were born with them, just things to keep bad guys out of the body. So, they protect against a bunch of different types of invaders, whether it's bacteria, whether it's a virus, anything like that. And they respond immediately. So this is like if you get a splinter, this is the stuff that's immediately responding to the bacteria that would be on the splinter that got into your skin. For adaptive, this is when we have a specific response to an invader. So like when they say that in your lifetime you will only get the chicken pox once, is because of an adaptive response. We then have a specific defense mechanism for a specific type of foreign invader. So for the innate defense system, we're looking at our first line of defense. So we have our mechanical barriers, skin, earwax, cilia, whether that's within your nose or within your throat, gastric juices, so that if you swallow something that is toxic to you or has bad stuff, that hopefully it will be killed in the stomach before it moves on into your small intestine where it gets absorbed into the bloodstream. Tears, protecting your eyes, saliva, to protect and start breaking things down within your mouth before it gets any further. For the second line of defense, we have chemical barriers. So backup system to our first line of defense. So interferons, and we'll look at these on the next slides, but interferons are proteins that are going to stop viruses from replicating. Having a fever, the inflammatory response where you swell up, and then phagocytes. So interferons are just these proteins that get released in the body, and they keep viruses from replicating. So remember, you can't kill a virus, but you can prevent it from replicating. With a fever, then I don't know if you guys have heard the phrase to try to ride out a fever instead of immediately taking a medication that will reduce a fever. Fever is actually a good thing because it reduces how much iron is on your blood, and that is what bacteria will feed on when it enters your body. And so if you reduce its food source, you can starve out a cold. Phagocytic cells attack better in high temperatures. Remember, high temperature is going to increase the metabolic rate of everything, so everything moves faster, so those cells can move around faster and get to the bacteria or whatever is causing you to be ill. For the inflammatory response, we have a bunch of increased blood flow to an area, which is going to be causing swelling. With all that blood flow, remember that blood also carries heat, and so the area that is swollen will also feel hot. And because of all that blood, remember, blood is red, and so it causes redness in the area, and all of that excess amount of cells and fluid and stretching in an area is going to increase pain as well. But all of this does help with trapping the infection, whatever is there, and then allows time for the neutrophils to get there and kill off any of the bacteria or whatever is there in that isolated area where it's swollen. So looking at the inflammatory response, we're showing here that you've been pricked by a pin. And so when that happens, out in our skin, we have these macrophages that will say, hey, bad guys have gotten here. And so then they're going to be releasing different chemical signals that are going to attract other cells. So these are starting to say, hey, we've got things here that we don't want, and so we're going to start clotting around this because we have a break in the skin. And we don't want to lose any more blood that way. And then as that occurs, then we get over here and our other phagocytic cells leave the bloodstream. Remember, that's chemotaxis. They leave the bloodstream and start attacking those different bacterial cells. Whoops. And then they eat up the rest of it, and then our area basically just is healed by the end of all of that inflammatory response. So with phagocytosis, we've got our neutrophils and our monocytes, which we learned about back in the blood system or circulatory system when looking at the blood. And remember that neutrophils are the ones that are most abundant in the whole body. And their killing strategy, they leave the bloodstream and go to the cells that they are trying to attack. And they eat them up. They do phagocytosis. For monocytes, and I'm not sure if you are getting all of this on your screen, I apologize. Monocytes, there are obviously way fewer of them than there are neutrophils. But they also leave the bloodstream and go attack whatever it is that they're going to eat up, and then they eat them up. Basically it. They work pretty much the same. They're just different cells in particular. This is a picture of a macrophage that is extending little arms out to grab bacteria, and then it will engulf that to swallow it up. For our third line of defense, this is considered a specific defense or adaptive defense. And this develops in the 3rd month after conception. So while baby is growing inside of mom, after 3 months of that occurring is when we start building this. They produce T cells and B cells. These are your lymphocytes that develop either in the thymus or in the bone marrow. So T cells in the thymus, B cells in the bone marrow. And these are the ones that are going to target specific bacteria or specific viruses when they enter your body. When these cells are forming, remember they start as stem cells in the bone marrow, and then we could have had hematopoiesis where they became red blood cells, or other types of blood cells, and they could also undergo lymphopoiesis and become one of these lymphatic cells. So the ones that leave the bone marrow and go to the thymus are the T lymphocytes or T cells. If they stay in the bone marrow or really close by, then those are considered B cells or B lymphocytes. So this is just a diagram here showing you that as they have formed in the bone marrow, then they go to the thymus. Remember, the thymus sits on top of the heart. After they've developed there, then they head off to other lymph tissue areas. So whether it's the lymph node, the spleen, we won't get into GALT, but that's where they will be waiting afterward. So with the immune system, it develops before you're born. Your body takes inventory and says, these are all of the things that belong to me. They are supposed to be here. And then, because we've said all of these things belong here, then we're able to figure out if something arrives that does not belong here. So we are able to recognize non-self. When we encounter a non-self particle, macrophages are going to go and destroy them. When we have that, then we'll have helper T cells, which basically do assistance, like in basketball, right? You get an assist when you throw the ball and then the other person scores. They will activate our killer T cells and B cells, which will go around and actually engulf our other invader organisms. For cell-mediated versus antibody-mediated, For cell-mediated, we just have that cells go out and attack whatever foreign particles have arrived. Versus antibody-mediated immunity, we're going to actually attach little antibodies onto the invader cells, and then that will disable them. They can no longer do their actions. And then we'll have suppressor T cells, which are going to suppress. They will stop the action of the immune system once the invaders have been destroyed. So we have to tell it to stop at some point, otherwise we'll develop an autoimmune disorder. So suppressor T cells. Some B cells and killer T cells may become memory cells, which means that at this point, then if that bad guy comes into the body again, our body already can instantly get rid of it, or, kind of instantly get rid of it so that it's not giving you a terrible cold again. The idea that you can't get the same flu twice comes from these memory cells. This video is just an interesting view of the immune system. It's not like real stuff, it's analogies, but if you want to take a look at it, you can. I can't show it in this because this is posted to YouTube, and so copyright. So then we get to active versus passive immunity. Active immunity is when your body actually attacks whatever virus or anything that comes in. Versus passive is when you don't actually get it. You get antibodies from someone else. So the active immunity, you can get it naturally or artificially. For naturally, it means that you got the bacteria or virus and your body fights it off. But we also now have an artificial way of getting active immunity where you get a vaccine. And can I move this down? Cool. Where you get a vaccine and you don't have to really go through as big of a process. But this is like when people are like, I got the vaccine and I got sick. Yes, you did. But not very much because it was a weakened version of the virus. But you artificially acquired it, but your body is still undergoing active immunity. Versus passive immunity is when you get someone else's antibodies. So this can be naturally from mother to her fetus across the placenta, or you can get it artificially. So if you had like a blood transfusion or something like that, then you would get that person's white blood cells. And in this process of passive immunity, you don't end up with memory cells staying and providing that to you because you're only getting borrowed antibodies. So looking at this all as a summary, you can read through that. I'm running out of time that is allowed on this recording. I want to get to allergies real quick. So allergic reaction, pause this and then go through and check the answers. Okay, so allergy, immune attack against a non-harmful substance. Two types, delayed reaction and an immediate reaction. For delayed reactions, this is when we have things like poison ivy, food. Generally, we have a rash that occurs versus an immediate reaction is when you think of like a person with the peanut allergy and they have anaphylactic shock. Symptoms of allergies, dilation of blood vessels, so redness, swollen tissue because of an excess amount of blood in the area, increased mucus production, and contraction of the bronchial tubes, which is when we end up having it being difficult to breathe. And then true or false for all of these. Pause it and then test yourself. And I'm out of time. So see you next time.